I promised I'll be back. In this video, we will talk about how to handle failure in Scala. I am Daniel, let's get to it. So if in the previous video we dealt with nulls, in this video we will deal with exceptions, which are the other pain in the neck as JVM programmers. By now you know how to throw in catch exceptions, and you know about the try catch finally expression. The problem with that is that multiple try-catch expressions make the code incredibly hard to follow, and you can't really chain multiple try-catch exceptions or operations that are prone to failure. And if we don't do them at all, we might end up with exceptions being blown in your face. So we need an appropriate data type, and in Scala, that's called try. So try is a wrapper over a computation that might either succeed with a value or fail with some kind of throwable. This is the definition of the try abstract class, and it's extended by two case classes, either for failed computation and for success computations. Failure holds the throwable that would have been thrown if you had run the computation by yourself, and success wraps the value obtained by that computation. Let's see this in practice. So as usual, let's create a Scala application. Let's call this handling failure. Make this an object, of course, and extends app. So, the way that we would use try is to either create success and failure explicitly. So let's call a success, for example, with success, we need to import this with some kind of value, let's say 3, and a failure would be constructed by, say, a failure to be a failure of, and I need to import this. So notice I'm importing both failure and success, and I'm going to pass in a new runtime exception, say super failure. All right, so if I try to print these out, a success and a failure, watch what happens. So we have success 3 and a failure with a runtime exception with the message that I passed in. Most of the time, you don't need to construct success and failure yourself, because the try companion objects apply method actually takes care of that for you. So say, for example, like with the options, we have an unsafe method, which says it returns a string, but through some code flow, it throws new runtime exception, saying no string for you, Buster. Not throws, but throw. Okay. The way that you would call unsafe method would be, let's say, potential failure is to use try with unsafe method. Now, of course, we need to import try. So try, failure, and success are in the Scala util package, and you need to import them. Let's print potential failure. So I run this, and I see the failure with the runtime exception, no string for you, Buster. Now notice that my program didn't crash, although I called unsafe method, because try took care to catch my exception and wrap it up in a failure if it got caught. So this is how you construct try objects via the apply method. All right, some syntax sugar used in practice is to say, let's call this another potential failure, is to say try and then a space and then curly brace and put in some code here that might throw. Okay, so just as you would do with a simple try with a lowercase t, we call the try apply method with whatever you pass in here. So this is how you use tries in practice. Let's deal with some utilities. First, you can test whether a try is a failure or a success. So if I print line potential failure is success, then this is a boolean telling you if the code that you wrote, which was wrapped in the potential failure, has succeeded or not. In this case, it's false because we have an exception inside. Of course, we also have is failure. We also have, like options do, or else. So say, for example, that somebody gave you this unsafe method API, and you had your own backup method, which says it returns a string, but it actually returns a valid result, right? Now, the way that you would chain unsafe method and backup method would be to say fallback try, let's call this like that, would be to say try unsafe method, and if that thing fails, say or else try backup method. All right, so just like options. So if I print line fallback try, I'm going to see a success with a valid result. Okay, so this is how you use unsafe APIs. If you are designing the API, so if you design the API, then if you know that your code might throw an exception, wrap your computation in a try instead. So I'll define a better unsafe method to return a try of string. And if you know that one of your code paths will throw an exception, just wrap that in a failure. New runtime exception. Right? And your backup method, let's say better backup method, which returns a try of string, and in this case returns success with a valid result. Now, a better way to use this new better API is to say, let's say better fallback is better unsafe method or else better fallback method or the backup method. So this is so much more readable. So I think you got the analogy to options. So whenever you have a hunch that your code might return null, use options. If you think that your code might throw exceptions, use try. All right. Of course, try, the try type, also has map, flat map, and filter. Of course, if I say print line a success map and I multiply the element by 2, I'm also going to get a success with the new value 6. If I print a success flat map and then I wrap another success with say the value times 10, let's pass in a correct lambda here, success of x times 10, then I will get a success of, in this case, 3 times 10. And filtering is the only thing that might turn a success into a failure. So if I say a success.filter, and let's pass in the predicate that the value should be bigger than 10, then this success will turn into a failure, and the failure will contain an exception. So let's run these and see what we get. So we get success of 6, of course, and then success of 30 from the flat map, and then the failed predicate here will turn into a failure with no such element exception. Predicate does not hold for 3. And of course, given map, flat map, and filter means we can use 4 comprehensions. All right, but I'll leave you to test these in another hard exercise. Again, we're dealing with a situation where we want to connect to a server. So, exercise. So let's say we have a value called hostname, which is either an IP or a local host or something like that. Let's just assume it's localhost for this simulation. And a port, let's say this is 8080. And we have a small method called render HTML, which gets a page as a string and just prints it to the screen. So in this small scenario, we will try to obtain a connection from a server, and given the connection, we will try to obtain an HTML page from the server, and given the page, we'll try to print it to the console. All right. So we're given a little class called connection, and this little connection class has a small method called, say, get, and this receives a URL, which is a string, and it will return a string, which in this simulation will mean an HTML page. And the implementation is going to be, I'm going to instantiate random equals new random with system nanotime. Okay, and if this random decides, next boolean, then I will return a success, in this case a string with HTML and a body and HTML, right? So this will mean that you've fetched the page successfully. Otherwise, I'm going to throw an exception. So new runtime exception. And let's just say that the connection is flaky and will return connection interrupted. Okay, so this simulates a flaky connection. If the connection is interrupted, then this will throw an exception in your face. If the connection holds, then you will fetch the HTML page. Your purpose is to render that HTML page if you get it. Now, we have another class, actually an object. Let's call this HTTP service. Again, this also has some kind of random. I'm actually going to copy this over. Okay. And this also has a method called getConnection with a host, which is a string, and a port, which is a string. This will return a connection. And the implementation is, again, not up to you. This is written by someone else. But the actual implementation is if random.nextBoolean, then it will return a new connection. Otherwise, again, it will throw an exception in your face. Let's just say that someone else took the port or something like that. This often happens in practice. Connections are stolen by other processes. All right, cool. So given this scenario here, I want you, so the purpose of the exercise is to try to print this guy if you obtain a connection, if you obtain the page from that connection. So if you get the HTML page from the connection, print it to the console. So that is call render HTML. So you have a lot of code here that might throw exceptions in your face. And if you manage to get past the exceptions and actually obtain valid values, I want you to print them out to the console. Again, like the options exercise, this is probably not intuitive right off the bat. I want you to take a minute to think about this, and I will come back with a solution. So, I'm back. What do we have here? We have all sorts of unsafe APIs. We have a method that can return a string but can throw an exception, and we have a method called getConnection that can return a connection, but it can throw an exception in my face. So the first thing that I want to do is to wrap these into a try. Now, in practice, you probably don't have access to these implementations, so you need to implement your own methods outside, but I do, so I'm going to cheat and I'm going to add some safe APIs inside. All right. Okay, so I'm going to define a getSafe method that given a URL string, will return a try of string. And this will return try with get URL. Okay, and same with get connection below. So these methods are very simple. So let's call this get safe connection with a host and a port. And instead of connection, I'm going to return a try of connection. And the implementation is going to be try get connection with a host and a port. Okay, so by wrapping these in a try, I'm basically containing the exceptions that might be thrown along the way. So now that we have our safe APIs, let's just create our connections. So I'm going to create a val, call this possible connection, which is get safe connection from HTTP service. So HTTP service dot get safe connection with the host and the port that I had earlier here. Okay, let's just assume that these are valid values. Host is a string and port is a string. Cannot resolve host name, of course. Let's just call it host. Okay, now given the possible connection, which might be a success, might be a failure, let's call this possible HTML. And this will be the result of possible connection.flatMap. Now, given the connection, which might or might not be there, I will try to get safe. So connection.getSafe, the URL, which say it's /home or something like that. We can pass in any kind of string that we want. So possible HTML is a try of string, which might be a string, which is our HTML, or it might be an exception. Now, given the possible HTML, which might or might not be there, I'm just going to call possible HTML dot for each render HTML. And this is my solution. So if the stars align, I'm going to get a connection, and I'm not going to get thrown exception. And if I get a connection, I might get an HTML out of it. And if I do get an HTML, I want to render it to the console. All right. So let's right-click and run this and hope the planets align. I don't get anything. All right, we get an HTML. So this means that I've obtained both a connection and the HTML out of it. The shorthand version would be to just chain all these calls. So we'll say HTTP service dot get safe connection with a host and a port, and then say flatMap. Given the connection, I'm going to say connection.getSafe, the URL /home, and then map, or for each, render HTML. So this is the shorthand version, which is a chain of flatMap and for each. There's also a for comprehension version. So you now know that flatMap and for each can be turned into a for comprehension. So we say for, and given a connection obtained by saying HTTP service dot get safe connection with host and port. So given this connection and no exception thrown in my face, now given the HTML page obtained by connection.getSafe, let's call /home, then render HTML. So this is the for comprehension version of this chained version that we wrote above. These two are completely equivalent. In an imperative language, the equivalent logic would have been try and say connection equals HTTP service dot get connection with a host and a port, then catch some kind of exception, and then inside, after you obtain the connection, you try again, and inside you would get connection dot get HTML, I guess. All right, get with /home, and then another catch, some other exception, and finally, after you got home, you try to render HTML with page. So this is the equivalent logic in an imperative language with these two tries nested. What if you had 10 tries? The code is barely readable as it is. What if you had 10 nested tries? What a nightmare. Alright, so you got the style of thinking from options already. I think try is not so much of a shocker anymore. So we use try to handle exceptions gracefully and to wrap computations that might fail or not. So we avoid runtime exceptions due to on-caught exceptions, either because we're careless or because there are too many cases to consider. We also avoid an endless spaghetti code of try catches. So try is a functional way of dealing with possibly failed computations, and you've seen utilities for those. You've seen map, flatmap, and filter in the latest exercise. You've seen or else, and there are others to consider, for example, fold or to list or conversion to options. Now remember, if you are dealing with unsafe APIs that might throw in exceptions and you are the designer of those APIs, if you think your code might throw an exception, use try instead. Alright, one hell of a session in functional programming. I'm really proud of you. This is really not easy. I'm Daniel. Let's wrap up this section and let's get back to pattern matching, which is one of Scala's most powerful features. I'll see you soon.